Because here's the deal. I'm just going to go straight to the directions before we go through the problem up here. It says write a compound inequality function to model each situation. Then find the balance after the given number of years. There are two things to do again. So would you write now with your pencil? Will you go down here and write that when we are working these problems, the first thing you will do, will write the function that will model the situation. It will have a y in it, and it will have a t. It will have a capital A in it, excuse me. Instead of a little y today, it will be capital A. It will have a capital A in it, and it will have a little t. And then you will go and do the second part, get the second answer, find the amount. What's that balance? Find that A value given a t value. Okay? So let's go up here and look through and put a box around this right here, because it's kind of a big, a little bit involved formula. A type of exponential growth involves finding compound interest. This is a very common thing in our everyday lives. And hopefully, if you're not already starting to save money, at some point you will. In other words, when you put some money into an account, you're going to want them to give you not just simple interest, or at the end of a year, they will, if they said they're going to pay you 5% interest, they're not going to calculate that 5% interest till the end of the year. You're not going to get anything on it until you've kept it in there that whole year, and all you're going to get is 5% of your balance. Whereas compound interest, what that does is, if they say they will compound it monthly, they're going to take your balance, and at the end of the month, they're going to apply that interest to it, add it into your account, and now for the next month, you're not only earning interest on what was in there, but that free money they gave you the month before, that interest that you earned the month before. So it's like you're earning interest on top of the interest, on top of the interest, on top of the interest. You're also getting some extra money. So you want it to be compounded. So when we are not using just a simple interest formula, this is what we did on Friday. That would be a simple interest formula. If they're paying you 5%, you're going to change 5% to a decimal. You're going to add it to 1. You'd have 1.05. And you would take that times your amount that you had in there. And then if it's you're only going to have it in there for 1 year, you take the first hour, blah, blah, blah. Simple interest. But when we have compounding interest, we have more going on. So these are all important things. A, you're going to know what A is standing for in the formula. It's the total balance after a given amount of time. How much is in the account? P. So A is taking the place of what in our exponential function? Y. It's taking the place of Y. P is the original amount. It's taking the place of what? In our original little a, right? Our little a. Okay? R is just like it was on Friday. It's being added to 1 or it's being subtracted if it's exponential decay. Well, we're talking exponential growth here. So R is still the amount, the interest rate changed to a decimal. N is new in here. N is the number of times the interest is compounded in 1 year. So when I said compounded monthly, how many times would that happen in a year?
12 times.
Why 12?
Because there's 12 months in a year.
It's 12 months in a year. So our N value would be 12 in that case. How many times are they going to compound it in 1 year? And then T is going to be the number of years. So those are all variables involved in that function that you're going to have to be able to put the appropriate thing in their location. Yes, Mikhail?
So T is years, not N is like days a month.
No, N is actually how many times during the year, during 1 year's time. So if they're compounding monthly, it would be 12. If it was compounding quarterly, how many quarters are there in a year?
4.
4. There's 4 quarters in lots of things, right? 4 quarters. Kelvin, head up. Kelvin, would you tell me if we did have it compounded annually, how many times would that be? How many times does that happen in a year? Annually. help them out, you know, give them a kick in the butt here? How much is it? No, you don't really need to. Annually. What would annually be? You don't know?
And is it annually once?
Once. Once a year. What if they're going to do it daily? Oh, that'd be really sweet. Daily. Your end would be 365 because there's 365 days in a year. So right now we're just talking about what would the end be, according to how often you're going to compound it. Okay, so here's one where somebody had $15,000 to invest. That was one of you guys, right? $15,000 to invest. At a rate of 3%, which nowadays that would actually be pretty good, compounded quarterly. So you're supposed to write an interest function, compound interest function for that, and then find it after 8 years. So notice, 15,000 in this case, let's write that out. Let's write that over here. 15,000 is the p-value. P equals 15,000. Well, the other thing that got replaced in there is the R value. The R value is how much? 0.03 is 3%. N equals 4. Why is N equal 4? Because it was compounded quarterly. Okay, those are the only things we really need to know. We need to figure out how much money, what's the principal, how much money is going to get put in, and then what's the rate of interest, what percent change to a decimal, and how many times will this happen throughout the year. So their number one answer is right here. There's their number one answer. A, capital A will still be in there. This is going to show A represents the amount that would be in the account after you take the $15,000 and multiply it by 1.0075. Would you verify on your calculator that 1 plus 0.03 divided by 4 becomes that 1.0075? Is that real?
What?
Everybody needs their calculator out there. This is going to be impossible. Well, it's going to be laborious without a calculator. So get busy. Get your calculator out and decide, is this right here, we're checking them out right here, does this really become that?
Yes.
Now, you're going to have to make sure you know how to put in your calculator correctly so that the calculator does the dividing of the 0.03 by 4 first, and then it goes back and adds it to 1. So you got to know, how should I put that in to make that happen on my calculator? So you should end up with 1.0075, and if you don't, you're not putting it in right. Anybody need help? Okay. Then number 2, their final answer is actually this right here because they wrote it in a sentence. After they substituted 8 in for the t value, what's the next thing they had to do after they took it time, after they put the 8 in for the t value?
You have to multiply 4 by 8.
Yeah, because the formula says nt, 4 times t. So when we put that t value of 8 in, we have to multiply the 4 times the 8 first of all and get 32. And then after you have that, now you're ready to do basically what we've done before. Yes, Michaela?
Why don't you put the 8 in right away?
Because we want our model to represent no matter how many years you keep it in for. So when we leave it just t, we can use it for anything we want. I can tell you to do it for 2 years, Abby to do it for 4, Faith to do it for 5, Julia to do it for 10, Noah to do it for 16, and so on. Okay, that makes sense? We can all use our model. We all have the same model, we just have different t values, that's all. Okay, so let's go practice this. Number 1, we have $17,000 invested at 3%, compounded annually, and then we're supposed to figure out how much would be in the account after 6 years. So number 1. Okay, first of all, let's do this though. Let's identify what all of these things would be representing. 17,000 would be our principal, our P. Like our starting amount. Our little a, but it's called capital P in this. Our next thing they tell us is 3%. What would that be?
Or
That's our R value, and what would we, how would we,
0.03.
.03. 3% as a decimal is .03. The next information they give us is compounded annually. What's that tell us?
But it's happening every so often.
How often is it happening in the year?
6 years.
Once a year. So
Once every
that's
6 years.
no, that's our compounded annually. That's our n value. N equals 1. Those of you who are tuned out better start tuning in. And then last but not least, in the very end, what is that 6 in step number 2? What is that 6 going to represent? T. Okay. So maybe what we should do is put a 2 here and a 1 here so we know these are all going to get used in the first one. And that T equals 6 is not part of our first problem. It's part of the second answer. Okay, so in number 1, we are going to substitute into our, let's write our formula down first. Capital A, amount in the account after a certain amount of time is equal to capital P times, in parentheses, that 1 plus, but this time it's not plus R, it's plus R what? Divided by N, R over N. How many times will they give that rate to you during the year? So they have to divide that rate up. And then it's raised to the NT power. Every time you write it down like this, you will get it memorized. So capital A is going to stay capital A. What's going in for P? 17,000. 1 is 1. RR this time is 0.03 divided by our N value of 1. And 1 times T in the power, in the exponent. We're not done though, we're going to clean this up. We're going to take what's inside those parentheses and we're going to rewrite it. And we're going to clean up our exponent if we can also. Okay? So what would our model for this one look like? Our 17,000 is going to stay 17,000. What happens inside those parentheses? Are you kidding me? You're using your calculator for this? 0.03 divided by 1 is what?
7.
No. 0.03 divided by 1 is 0.03. 0.03 added to 1 is?
0.07.
Were you really using your calculator for that? Are you kidding me?
No.
Okay, and 1T, can that be cleaned up? Just a T, yeah, we don't really need it there in this one. So this one is looking not any longer, it doesn't really look like a compound interest function, it kind of starts to look like just an exponential growth. Add the R value to 1 and take it to the T power. But that's only because it was compounded annually. Okay? This is our first answer, circle it. I will not stamp papers tomorrow without that first answer. Clean up like that. Now we will use our model to do step number 2, and in step number 2 it says, do it when T is equal to 6. So we write down what our model is, and we substitute in our T value. This time we won't take our T times anything. We're going to do just like we did on Friday. We're going to figure out what this is. Did we do this all in one step on Friday?
No.
Did I make you write down what 1.03 to the 6th power was?
Yes.
I did, huh? I don't remember that. Oh, evil of me. Okay, let's try it without doing that. Let's see if we can do it. Once you figure out how much money is in this account, given that T is equal to 6. Do it all in one step without having to stop and write down another step. I'll put the answer up there, what you should get after I see everybody attempting it. So we might be waiting on Calvin and Noah and Aurora for a while.
I'm done.
You're done? Okay. You too, Aurora?
How I calculate you do it from the beginning.
will you check with notes, see if you guys agree? After you're done, I'm sorry, will you check with the row and see if you guys agree? After you guys are done, check to see if you agree. Same thing with these tables. After you get done, check to see if you agree with your neighbor. Round it to the nearest what? What do we round these to? The nearest hundredth, which is pennies, right?
Yep.
Okay, which team is feeling confident they have the right answer and they want to share it? I saw Devontae's hand half up. He's gonna answer. He was really scratching his head.
20,298
$298 and $298, $20,298 and 89 cents. Do the rest of the teams agree with him?
You said 89.
Yeah, that's what he said, right? Did I hear you right? Okay. You guys agree with him? No? You do?
Well, I agree with him, but I have my answer differently. I have my answer differently.
How could your answer be different?
I rounded the 8 to a 9, so it's
No.
20,299.
No, we're rounding it to the nearest cent, to the nearest dollar, to the nearest cent. 89 cents, not $99. Isn't that what I'm hearing? You rounded it to $99, $299.
Rounded that up because I rounded the cents up, so if you round the cents up, you gotta round up the dollars.
No, no. You look in the thousands place. Oh, that was not necessary. You look in the thousands place. What's in the thousands place of this one? A 9. And what's in the hundreds place? An 8. So all we do is look at the thousands place and say to the hundreds place, should I round you up? So should that 88 cents be rounded to 89 cents? Yes, it should. Okay, so no, we can't say, well, I did some other kind of rounding. No, we're going to. Okay, go ahead and get the next one. I want all your P and R and N and T and all those things identified first. So in step number 1, remember we identify the P, the R, and the N. Step number 2, we identify the T. And when you're done, Calvin, come on up here and fill it in for me on the smartboard. Because that's the only way I'll get to engage you all, and that's all I'll do. Okay, we're waiting on you, Calvin. Come in, fill in the blanks when you're ready. Rub your fingers, man. Okay, thanks, Calvin. Do we agree with him?
No.
Where would there be disagreement?
On the end.
This is a 1, right? It just kind of skipped. It's not an exclamation point. Okay. So this is 23,000, right? Okay. Do we agree with that?
Yes.
Yeah. Okay. R is 0.02 is decimal point. Kind of just took a little jump. Do we agree with that?
Yes.
Yeah. Okay. Is N equals 1? Why not?
Because it's compounded quarterly.
N means how many times during a year will they give you that interest? They're going to do it quarterly, which means that would be that means not every, but 4 times a year. How about the T? Do we agree with that? Okay, go ahead and work this problem out. Let's see if we all agree. Thank you, Calvin. Check me out when you're done and see if you agree. Can we go with the model that I have? My model is circled like we should. So it stands out. Agree, disagree with me? Shake me up if I need to be shaped up. I have a good model. Some head shakers, so okay. So, and that's kind of like saying, you got 0.02, you got 2 pennies, you got to divide it between 4 people. That's kind of hard to do. What ends up happening is each person gets a half a penny. Okay, that's the answer for number 1. Now we take our model and we use it to get answer number 2. Now, there's going to be 2 steps of work here. Because we have to take that, yeah? I got an extra 0 there?
Yep.
I thought I just saw that when I was going to write the thing next to it. Thank you, Cody. Because we're going to have to substitute 8 in for t, so we're going to be taking 4 times 8, aren't we? So we end up taking, before we put this in our calculator, we say, I really have 23,000 times 1.005 raised to the 32nd power. And now you can touch calculator, see if it'll give you your cent, your pennies. You always look at the thousands place. And you say, how much cents was it before I look at the thousands place? So here's what should happen when you in the tenths and hundredths place or in the money card, it would be 99 cents right now, with the 1 following it. Is that 1 big enough to take it past 99 cents? No, the number behind the pennies is not big enough to take it up another penny, so we're going to leave it 99 cents. So we're going to say that our amount in the account should be approximately $26,979.99, which hopefully should always end up larger than how much money was put in to start with, right? They're not charging us anything. Better not be when we're investing. Okay, any questions on using the compound interest formula? Because that's what you will do today. One of the things you'll do in your homework today. Okay, let's go to the back side where we're going to talk about a special type of exponential decay. And you need to pay attention here. You will use this all the time for half-life. This is the formula, which you put a little box around it here. This is the formula you will always use for half-life of a substance. Capital A being the final amount, how much is left. P being how much did you start with again. It's like our little a. And T, this is the part, I want you to underline this whole thing. T is not how many years, how many, it's how many half-lives will it go through in a given time period. So here's an example. They have Ismuth 212 has this number right here is not part of the formula. It's part of the name. Okay, it's the name of the substance. Has a half-life of approximately 60 seconds. What does half-life mean?
It means how long it's
In this one, after 60 seconds, what will happen? No.
Well, it's half-life will be over.
Half of what was there to start with will be left. After another 60 seconds, half of that amount will be gone and only half of it will be left. After another 60 seconds, half of that amount will be gone and only half of it will be left. So it keeps decreasing, and the amount of substance decays, and we don't have as much left. So it says find the amount left from a 25-gram sample So in this case, the 25 grams, I want you to put over here, P was 25 in this one. P was 25. And notice here, they do show us how they got T. They say they took 300 and divided it by 60 because we were supposed to figure out how much was left after 300 seconds. So in other words, they're saying the time frame is 300 seconds. How many times will it go through a 60-second half-life? How many 60 seconds are there in 300? Okay, so let's go on and practice. Write an exponential decay function to model each situation. Number one, then find the amount of the value after the given amount of time. So step number one in this one, the only thing we have to identify is this right here, P equals. So what's P equal in this one? 30, the starting amount. So number one, we'll substitute into our model 30 times 0.5. This will always be 0.5 because it's going to be, half of it's going to be gone every time. You keep multiplying by a half and to the T power. Okay, there's step number one. There's your first answer right there. Capital A still there, little t still there. Step number two, now we have to figure out what is our t. So t is going to be equal to the amount of days that it's going to go through, how many this is the time frame, and it's got a that's its half-life, I'm sorry. Its half-life is 8 days. So we're going to have to figure out how many 8 days are there in the total amount of time of 24 days. How many half-lives will it go through? It's going to go through 3. So half-life of about 8 days. So this is important piece of information. And then in 24 days, how many of those will it go through? So now we're ready to substitute into our model. Here's our model, first of all. Now we can put our t value in. So notice we're not putting 24. We're not putting 8. We're putting 3. How many half-lives will it go through? And then we'll be able to say how much of this original 30-gram sample is left. So A is equal to, we should be able to get a number that we don't need to do any rounding. What's it come out to? What's it come out to?
1.5.
No.
A equals 15. No.
Calculate it for me. What's it come out to?
3.75.
3.75. And these are what? Not dollars. What? No, how
Grams.
much of the substance is left? 3.75 grams of this substance. Okay, let's do one more. Sodium 24. That's part of its name. The 24 is not part of any, it's not our A or our P or our T or our anything like that. It's just part of the name. So we have our step number one where we identify our P value. What's our P in this one? 40. We're starting with 40 grams. So we will substitute into our formula that goes A equals P times 0.5 raised to the T power. So ours is going to be 40 times 0.5 to the T power. What's the model that would represent how much substance is left given some information about how much time is this decay going to go through? Okay, number two. How are we going to get our T value in this one? 60, the total amount, divided by the half-life of 15. We're figuring out how many half-lives will it go through. How many is it going to go through? 4. So we have A equals our model 40 times 0.5 raised to the T power. We'll substitute our 4 in for T. And again,
Rams are left.
after 4 half-lives. How much is left?
2.5.
Okay. Looks like you only got time to write down your assignment.